So right above, let's write out in kind of big. F of x is equal to x minus 1. Oop. And is that x squared?
Yeah.
Plus 2, all what?
Squared.
Squared or cubed? I see cubed.
It just looks like
All right. So the rule is, we're going to derive the first one, keep the second one, plus keep the first and derive the second, yes? Okay? So let's do a recall on this one. When I derive the first set, it's going to be what? 1. And then I'm going to keep the second one, all cubed, plus keep the first. Now, when I derive the second set, it is chain rule. So what number comes down? 3 comes down, and then I keep the inside. 1 less of that power is 2. And then I derive the inside. The inside derivative is 2x. Good on that so far? Okay? And then, let's see. Maybe this highlighter would be nice. From these two chunks that is separated by this plus or minus, in this case, it's going to be a plus sign. What is common between the first set and the second set that I could take out as a GCF? X squared plus 2, how many at most? 2 of them. So we have x squared plus 2, all squared. And because I'm thinking ahead, I'm going to use a bracket. Now, in my bracket of the first set, I did not take out all of them, right? So we have x squared plus 2 remaining. On my second one, I took out all of this squared. So let's simplify while I'm at it. 3 times 2x is 6x. And then I'm going to leave the x minus 1. And then it's a matter of simplifying everything on this side. So I'm going to focus just this right here. So that's going to give me x squared plus 2. When I distribute 6x, we get 6x squared minus 6x, correct? And then let's combine like terms. When I combine x squared and 6x squared, how many is that? 7x squared. And then I can't combine the next one since I have 1 with the x and 1 as a constant. And this, and what we took out is what I need, which is what? D? Very good. Now let's go to number 22. Again, I'm going to use a separate sheet of paper. We're looking at differentiating implicitly. The main thing that you have to remember, implicit differentiation is when you are deriving something without an x, what do you have to add? dy over dx. Here's 22. I think I passed it. Oh, it's on the back. Okay. I'm going to write really big right here, so bear with me. So it's asking us, given the following equation, can I get to this? So all we have to do is differentiate. So let me write this kind of big, and I'm going to call this one part A. So we have, because I know we have product rule, I like parentheses, so why not go ahead and separate it with it? If you've done this already, I want you to practice this one more time with me. And if you want to process by looking, I'm okay with it as well. How many product rules do I have here? 2. So derivative of the first one is what? 1. And I keep the second. Plus, I keep the first x. And when I derive y squared, it is 2y, and then dy over dx. Good on that one? The second piece. Let's just carry the negative with us, with the x. So if I derive this right here, I'm going to get what? Minus 3x squared. And then I keep the second piece, which is simply y. Plus, I keep the first one, which is negative x cubed. I should really write minus as one whole operation. But I'm going to stay true to the product rule. And then when I derive the y, what do we get?
1.
Just 1. Can I just write dy over dx? Yep. And derivative of a constant is how many? 0. So now let's kind of think about what to throw out. I need to get rid of, I need to move this one to the other side, move this one to the other side, and then factor out this one and this one inside the radical, not radical, parentheses. So I have dy over dx. In parentheses, I have 2xy. And for that one, we have minus x cubed. We're going to move this one over by subtracting. minus y squared. Move that one over by adding plus 3x squared y. And then all I need to do is divide everything by this guy, yes? So when I do, I'm going to get dy over dx is equal to, let's see the format that they had. They had the constant or coefficient first. And then they also had the other coefficient first, 2xy minus x cubed. Is that what I actually see on part A? It says make it into that, yes? So we go with part A? Okay, let's go to part B. Now part B says find the tangent line at x coordinate of what? When x equals 1. So for tangent line, I need to figure out what is my coordinate and then what is my slope. So for us to find out the y coordinate, can I plug it into the original up here? Yeah? Let's plug in the 1 up here. Plug in the 1 up here, it's going to give me just y squared. And that's going to give us minus y. And then when I move the 6 over, because we have to factor, we get minus 6 is equal to 0. Are we okay with how I got that? You plug in the 1. And then let's factor. Give me two numbers that will satisfy the product of negative 6 and combine to get negative 1.
Y minus 3.
Y minus 3 and y plus 2. So that means we have two scenarios. Y could be a 3 or y could be a negative 2. So I'm going to go ahead and write on here, okay, let's do one with 1 comma 3. Let's do another one with 1 comma negative 2. Good on that so far? Okay? And according to our rule, it was y minus y1, so y minus 3 is equal to, I'm going to put a little blank for the slope, and then x minus x1. And then for the next one, since we have two scenarios, we have y minus the negative 2 is plus 2 is equal to the blank that I'm going to plug it in a little bit, x minus 1. So my slope, don't we already have that slope formula that was given to us basically? So plug in 1 and 3 for each of them. So let's do that over here. My slope, we have 3 times the 1 all squared, my y is 3, minus 3 all squared, all divided by 2 times the 1 times the 3 minus 3 all cubed. What is my top going to give me? 0. So if I know my top is 0, and the bottom could be some messy negative, messy positive, doesn't matter. The bottom line is our slope is 0. Okay? So if you want to actually put in a number, you can. But I'm going to go ahead and tell you it's going to be 5. On the next one, let's do the same thing. We're plugging the 1 and negative 2. So we have 3, where's my equation? There you go. Times 1 all squared times negative 2 minus negative 2 all squared, all divided by 2 times the 1 times negative 2 minus negative 2 all cubed. Okay, see about computing the top piece, everybody. We get 3 times negative 2. Negative 10, very good. Okay, go ahead and compute the bottom then. These are smaller numbers, so it's not too bad. Negative 5, very good. So that means we have two scenarios of this tangent line and then the second tangent line. Good? Okay, part C. Evan, will you read part C out loud, please?
Find the x coordinate of each point on the curve where the tangent line is vertical.
So we want the tangent line to be vertical. If it is a vertical, is it 0 as our slope or undefined slope? Undefined. Right, Austin? Undefined slope? So that means our dy over dx, which is basically our slope, is going to be some number over 0. So my focus is basically the bottom. According to our equation, wasn't this our bottom basically? Right? So I'm going to set that equal to 0. So we have 2xy minus x cubed is equal to 0. And we need to factor out something. What is common between these two that I can factor out? the x. So I have 2y minus x squared is equal to 0. So my first scenario is x could equal 0. So let's plug in that x equals 0 into the original equation, the curve, not the slope function. So the original equation was, we had this equation. We're plugging in the 0. So we have 0 times, I know we don't know the y, and that's fine, minus 0 cubed times a y is equal to 6. Let's see if that statement is true. 0 times anything is 0. Same idea. Is 0 minus 0 ever 6? Never. So this number is irrelevant to us. But you still have to test it to show the AP graders, hey, I know what I did. I tested it. It didn't work out, so we're going to move on to the second portion. So here's our main focus right here. Let's set that equal to 0. 2y minus x squared is equal to 0. Okay, does your gut tell you to solve for x or y? Let's kind of go back to the question. The question says, find the x coordinate. If I'm finding the x coordinate, I want it in terms of x, meaning I want to solve for y. So for this one, if I were to do one go, that would be y is equal to x squared over 2. This is what I'm going to plug in into the original equation. The original equation is already on the top of the part A, so I'm not going to write that piece down. I should just stay with the pink. So we have x times x squared over 2, all squared, minus x cubed times x squared over 2 must equal 6. So that means we're solving for x. Let's simplify this. If I simplify all of this, that's going to give us x to the power of 5 all over 4. Are we okay with that? If I simplify all of this, that's going to give us minus x to the power of 5 over 2. So we don't like what's happening on the denominator because they are not what? They're not the same. So all I need to do is make 1 over 2 into a 4 by saying 2 over 4. So let me rewrite that piece. X fifth to the 4 minus 2x fifth to the 4 is equal to 6. Now, do I have a common denominator? So if I go ahead and combine, we get minus x to the 5th over 4 is equal to 6. And then we're going to add or multiply by 4 and divide it by negative 1. X to the power of 5 is equal to negative 24. And we're almost done. I need to do 5th root. So when I do 5th root, these two cancel. And I know our number is very ugly, and that is why it is free response. 5th root of negative 24. And that's all you had to find.